This is called curl. But we want to represent it into represent in the form of curvilinear coordinate, because that will be like a template for these operators, for this thing. So you can use it to not just doing working with a spherical coordinate or working with a cylindrical coordinate. You be used in working with any other coordinate invented by performing by plug into this general form of operators like this. Okay, so we work it out. So later, like the next weeks, maybe we go deeper in the application of this lah. Macam in Green theorem, Stokes theorem, Green theorem, dengar Green theorem, Stokes theorem, kan? Or that apa lagi? Divergence theorem, Gauss theorem, divergence. Being used a lot in physics. But this we want to go deeper in this. Deeper in the mathematics behind this, not just apply. Right? Later we go apply. Next week lah maybe. Okay, let's start with last time we work on this. Oh shit. Okay, dia longer. Never mind. dr become what? You remember? dphi, right? Right? If you work on the latest one, if you work on like say for Cartesian coordinate, using this one is become dx I phi I plus d phi dy j d phi dz k, and then you dot product with the position vector xi d. Okay, the different position vector, this means this dx, okay, dx I dy j plus dz k, the position. You get this. I just want to refresh this thing back. So dx plus d phi plus dy plus d phi dz, and this is by chain rule. If you have by chain rule, we can say that this is d phi, because by chain rule, if you remember, chain rule is very important. Is phi, you have it's a function of x, y, and z. Is if any d phi or any delta phi or whatever, you will be always in this form. Okay, it's always in this form. This is chain rule. So that's why this one become this one, because this one operate with, this is del phi or gradient of phi dot product with dr, the difference in position vector. You got this. So this is the chain rule. Okay. Now we want to generalize this thing in the form of curvilinear coordinate. And this is d phi. Okay. So let's say we can say, because this, if you look at this, this is del of phi. It is a vector. It is a vector, right? It is a vector. Is I, j, k is a vector. So we can say that this is, let's say, for example, in more general case, the I, j, k is represented as E1, which is the basis vector E1, and then this is, let's say, F some component F1, and this two E2 component is 2, and this 3 component E3. So this component you can represent it more in more general case. Okay. Now this with dr. So what is dr? So dr is a function of u1, u2, u3. Okay, r is function of u1, u2, u3. Now we can say that dr by chains rule, which is very important. You must know this: d1 du1 plus dr du2 plus dr du3 du3. Okay, so we can say dr is this as chains rule. Okay, this is more general form of coordinate. No more this one Cartesian coordinate, very easy. This one we want to generalize it into a curvilinear form of coordinate, form of del operator, curvilinear form of Laplacian operator. Okay. Okay, we have this, and you know this one from the beginning of my lecture last time. E1, say for example, E1, the basis vector is dr du1 over dr du1. Okay, remember? Okay, and this is, we call it, this particular modulus of dr du is, we call it a scale factor. A scale factor. So this is called, so we can say that this is dr du over h, the scale factor. Okay, the scale factor. Scale factor, we name it as, we symbolize it as, like dr du1 scale factor is h1. Okay, H1. So this is h1. And so same goes to other basis vector. E2 will be dr du1 over h1. Okay, E3 is dr du3 over h3. Okay, faham? Understood, everybody? Yeah, very good. Okay. Now we can see dr du1, this, which is this one, dr du2, du2, sorry. So anybody who can say, so dr du2 is E2. So dr du3 over h3 is E3. So this means that dr du1 is h1 multiplied with E1. So we can say h1 E1 du1. This one is h2 E2 du2. See? And then h3 E3 du3. Okay? So we rearrange it, make it this is just a component, and this basis vector we rearrange it. We rearrange it, so the R we have h1 E1 h1 du1 E1 plus h2 du2 E2. Okay, and then plus h3 du3 E3. Oh, we got that. So H3 never mind, you have a new, before you graduate, hopefully you get a new this, you okay, all right. H1 du, okay, all right. Now we have this. Oh, now let's find d phi. What is d phi? So d phi is del phi over dot product with dr. Now we plug in that one, f1 e1, which is the gradient of phi in curvilinear coordinate, plus okay, dot product with the difference in position vector in a curvilinear coordinate, which is we have h1 du1 e1 plus h2 du2 e2 plus h3 du3 a3. Okay, so what will you have? We just concentrate on dot product e1 because that will be 1. Other things e1 e2 e1 e3 e1 e what will be 0. Okay, so what left is just even e1 dot e1 they become 1. e1 dot e1 dot product with e1 is become 1. So become what we have is f1 h1. Okay, we can say anything lah, but okay, h1 f1 du1 f1 h1 d1, okay, plus h2 f2 du2 plus h3 f3 du3. Okay, f1 f2 d3. But how does this relate to d phi? D phi we can get it from chain rule. Again, chain rule, very important. By how? You see, I think I derived already. This one. Oh, but this one in Cartesian coordinate. Okay. Now this is in curvilinear coordinate. It's the same thing, which is this is a function of u1, u2, and u3. So phi is a function of u1, u2, u3. That's it. So we can say that the difference in phi is d by using chain rule, d phi du1, d phi du1, du1, okay, plus d phi du2, du2 plus d phi du3, du3. Okay, d phi du1. Okay, everybody. So far, okay? Okay, all right. So we can relate this thing because this is also d phi. Right? We can relate now. We can relate the h1 f1, h2 f2, h3 f3 to the d phi d1, d phi d2, d phi d3. Okay? So this thing is this, and this thing is this, and this thing is this. Right? So we can say that now d phi okay, you can say h1 f1 is this. Okay, now okay, now we want to relate to this. We want to relate to the gradient. This is what we call gradient of phi. Del operator, not dot product. Kalau dot product divergence, if dot product is divergent, just operate upon phi, which is we have that, we assume in the first place it is a vector which is f1 e1 f2 e3. Okay, so what is this in terms of f1? So we have f1 e1 plus f2 e2 plus f3 e3. So f1 h1 f1 H1 F1 is equal to d phi du1. So that means F1 is 1 over H1 d phi du1. Okay, H1 d phi du1. So we can say that now is this is 1 over H1 d du1. Not d phi, sorry. Okay. Okay, never d phi. So d phi, d phi, because this operator, so they operate already. So d phi d1, okay. If we want, and then E1, this one. So F1 is this one. The same pattern. The same pattern. So just give it. Du1, d phi du1. The same pattern for F2. So F2 is 1 over H2 d phi du2. Very easy. 1 over H2 d phi du2. This A 2, and then 1 over H3 d phi du3 E3. Okay. The basis vector E1, E2, E3. This is the component. So which is equal to this. So now, what is del operator in the? You can if you want to write just del operator for this in curvilinear coordinate, we just ignore this phi. We just put it in the form of operator. So we now we have apa call tengah-tengah. Okay, d phi 1 over H1. We take no d phi. No, this del is not operate upon d phi, just operator only. So the operator is this u1 E1 plus 1 over H2 du2 E2 plus 1 over H3 du3 E3. So this is the curve del in curvilinear coordinate. This is like a template of operator. I mean, if you want to work for cylindrical coordinate, you just have to find what is H1 in cylindrical coordinate, what is H2 in cylindrical coordinate, what is it? Just plug in, and you get it. You want to work in spherical coordinate, you just find what is H1, what is this U1, what is H2, what is U2, what is H3, what is 3 in spherical coordinate, and just plug in, you get it. Okay. So it's like template. And in anything, in any kind of coordinate system, you just define the H1. How to define it? I think my last lecture, H1 du1 du3 is my last lecture. I've shown you, right? You remember? The last lecture, if you want to, like for example, never mind. We come back to this later. Okay. Okay. Now we have this already. Now we want to find a little bit harder. What is del? Del in del operator, del Laplacian. This is Laplacian operator in curvilinear coordinate. This is being used a lot in fluid dynamics, in electromagnetic, in many things. Okay, in Schrödinger equation. Okay. Now we want to work a little bit complex again. A bit complex, not so complex lah, easy. But they have a lot of mathematical trick. Okay, now there is a mathematical trick here. Not a trick, is just okay. Now we want to find this. We want to find this Laplacian. So Laplacian, let's say Laplacian operate upon, let's say in Schrodinger equation, you will look something like this. Okay, what is this? You can mathematically you can separate this by using dot product with another del operate upon psi. So it is this can always be shown like this. Okay, this dot product, this Laplacian can be defined as this. We can show this in spherical Cartesian coordinate. I think I've shown in Cartesian coordinate. It's easy. For example, so this is the del, and this is in Cartesian coordinate. I just refresh the x psi plus d psi dy j plus d phi psi dz k, just to refresh you all. So this one is okay. The x I and dy j plus dz k, and then you dengan ni you a dot product with this. You can prove this ini in Cartesian coordinate, which is easy. So dot product I cancel, I become 1, ij 0 cancel. So what left is just d dx plus d dy psi plus d dz psi. So it become become this. So this is the Laplacian. So this is the Laplacian of psi is this. So Laplacian operator is just double double. This is in Cartesian, very easy. How about in spherical? It's a bit complicated. Cylindrical, even spherical coordinate lagi complicated. It's even more complicated. People just memorize it. But if you don't want to memorize, you want to develop from scratch, you have to know the curvilinear coordinate. Okay, you have to know the coordinate. From coordinate, you just make a template of this, in curvilinear coordinate form, and just plug in the h1, the du1, h2 du2, h3 du3, and you get the Laplacian in whatever coordinate system you want. Okay, now, so these are just to refresh why this become this. Look at using the simplest coordinate system, which is Cartesian coordinate, you can prove it. So now we want to expand this to get into the form of curvilinear coordinate. This one just to refresh you. Okay. This one boleh padam, okay? Okay, now we want to get this del psi, which is, we can say that this is we already proven, which is proven in the simplest way using Cartesian coordinate. Okay, from here, now we want to have this. Okay, but so it's like, let's say this thing we take it as this is a vector, you see? Because del, when operate upon some psi, some function, it still become a vector. Okay, so this is a vector, so we can say this is vector. So let's say we can say that is dot product with A. Dot product with A. Okay, some dot product with A. So, okay, now we have this dot product with A. So simplest. So this one, we tackle this one dot product. We try to find ins. We trying to find what we call the coordinate system, coordinate form of this. This called del dot A. We call it divergence. This is divergence. That divergence with A, dot product with A. This whole thing we call it divergence. Divergence of A. Okay, no mind. Let's say, okay, now we before we go, we rework on this. We work on this. We just try to what we call to expand a little bit more this divergence. Let's say we have that. Okay, what we call we have this. We have this del coordinate. We want to find. You see, there's a lot of divergence here. There's a lot of coordinate here. I mean, dot product here. We want to find some kind of something of this form, but we try to expand this to get more generalizing of del. Let's say, what is del U1? What is del U1? What happened to del if you this method is this exploration of this is more like using all kind of mathematics that we know in this case and do some tricks. We explore what happened to this, what happened to this. Okay, let's say now del operate on U1. What happened? Do you think what will happen? It's very easy. It only tackle here. du1, du1 over du2 become 0, right? du1 differentiate with du2, it becomes 0. du1 differentiate with du3, it becomes 0. What left is here only this portion. Okay, so we can say that, so du1 is what? Okay, then we just follow 1 over h1 du1 e1. The others is become 0. So d1 is 1. Okay, du1 is 1, of course. So it become e1 over h1. So what we have now is du1 is e1 over h1. Bukan V, apa ni, del U1, del U2 is E2 over H2, del U3 is E3 over H3. Very simple method. Even you can generalize it. UI, make a formula EI over HI. It depends on anything. Okay. Depends. So, I can be, in this case, I is 1, 2, 3, three-dimensional space. Okay. So now, what happen if we do another exploration? What happen if we du1 cross product with du2? What happened? It'll be very easy. E1 U1 H1 cross product E2 H2. You see? Right. Delta del U1 is E1 H1, del U2 is E2 H2. We get this. But cross product this one. E1 cross product with E2 become right on. H1 H2 is equal to this one. So now E3 is what? E3, we can say that E3 is they have a pattern in here. H1, H2, and then U1 cross product U2. So we have a pattern here. A pattern. 3, 1, 2. 3, 1, 2. See? A3, the basis vector itself is this. Okay? Because why we want to create this? Because later we want to, this can be expand A1, which is component of this vector A1, E1, which is more general, which is E1 plus A2, E2 plus A3, E3, and then you expand this, become A1, E1 plus A2, del divergence of A2, E2, and then plus divergence A3, E3. So we can expand this. Now we have this E3, we can plug into here, we can see what's going on. Okay? So now we have this. So far you understand this. How we can get this? Very easy, right? From here, shoop, shoop, shoop. So let us guess. What is E2? It always follow the positive commutation. I show you E1, 1, 2, 3 positive. Kalau terbalik, the other side negative. Okay? 2, A1, H2, after H2, H3, H1, right? Yeah, good. U1, right? So this one. The other one is E. We have already 2, 3, E1. E1. So H2, H3. H2, H3, and then del U2, U3. So we have that. Okay, got it? Okay, I naik atas. Okay, everybody. So from here, we explore again. Okay, I think this one. Which one? Okay, this one. Okay, we work. I erase this one. Okay. So we continue from there. So we have that already. Then we want to use that atas tu. Okay. From up there, del psi, and then del Laplacian. This we call it. This thing we want to call it. We call it Laplacian. Laplacian. Double del. Laplacian. Laplacian operate upon psi is equal to del dot product divergence with A. With A, actually last time we take it from del operator, del of psi or gradient of psi, which is equal to A, the vector of A, and then we can expand the vector of A is A1, E1, A2 plus A2, E2 plus A3, E3, and dot product with that, which is we can expand this thing, so we can expand this way. So the whole thing is equal to A1 E1 plus A2 E2 plus A3 E3. Can play this. Okay. So that means we have to find this. We have to find something, we expand it, and then we can relate to this. How are we going to do that? Okay, now, okay, we have this already. We have that E1, H1, 2. Now, we multiply. So what is A1, E1? That means A1, E1 which is H2, H3, right? A1, H2, A3, and then del, cross product with del U3. Okay? Alright? That okay? Which one? Processing, okay? This one, we want to get this. Okay? So, E1 we have already here. That one tadi. H1, H2, H3 using the positive computation, and then multiply with the gradient of U2, cross product with gradient of U3. Okay? The thing is now, we have this already. I mean, this thing lah. Okay? You have to find this one again. But we can see from this pattern, we don't need to focus on getting it. We can operate this. We can try to get a pattern out of it. Okay, this one A E because it's this one. So now del dot product with A E. How we going to do this? We have this like it is like del dot product gradient of A1, H1, H2, H3, because this H2, H3 here is E1, right? Tadi, E1, H3, and then this 2 cross 3. Okay? How we will do that? We can separate this. Let's say, for example, this one is just a number. This one is just a number. A1, H2, H3, just a number. H2, if you know, H2 is DU2, modulus DRU2. You get a number already. So H3, H1, H3 also that. A1 is a component of that vector A. Vector A, the component of that. Component of A1 component. So it's just a number also. So we take it this as a let's say what is it? Of just a number that we cannot clear A lah, A, small a. Here's number, and then this whole thing we take it as, now we want to use what we call this whole thing is like this one is a vector, okay? This one is a vector. No, not say this. We just say as a vector. So this is a vector. Vector B. This vector A, vector B. Okay, vector A small a. No, not vector. This is a scalar of A, which is this is a number. A scalar of A, and this is a vector of B. Because you see, even though cross product, a cross product of a divergent is still a vector. Betul tak, everybody? Let's say, for example, vector A. This one is vector. Divergence of U2 is a vector. Divergence of D is a vector. Okay, a vector cross product with another vector become still a vector. Betul tak? Okay, for example, I just refresh you all. Kan? So we can I, J, K, kan? AX, dia komponen dia, AY, AZ, BX, BY, BZ, and then you have all the component AX, AB, BZ, AY, BZ minus AZ, BY, and then this I, and then negative AX, BZ minus AZ, BY, and then this is J, and then and so forth. But that means this is I, this is J, K, a vector still. A vector still. So any cross product within of a vector cross product is still a vector. So that's why we call let's call this as a vector B. This is a vector, this is a vector, because del of operate upon U2 is a vector still. So this whole thing is a vector, this vector, and cross product become vector also. So I think this is just to refresh you why it's still vector, become a vector. So this. Okay, now this one. Now see del dot product with AB. Do you remember you study this? I think vector last time. Ada kan? Apa jadi? What happened? Become very easy. Just macam differentiate biasa, but you have to be careful with which one you want to dot product with. You always dot product with a vector, but you always do a gradient, because gradient must always be upon something else, some number, okay? Which is not necessarily a vector. So we can expand this thing A, this one, okay. Dot product with a vector B, plus B is a vector and dot product with del, and then operate upon A. There no more dot product, but because A is a number, is a something else. It's maybe a function, but A become a number. So you can just product. So this is like a identity of one of the vector operation lah. Del operation. Banyak. I think maybe you have seen this. Banyak identities there. You can play around with the identity. Never mind. I will post. I think in my notes ada, in books pun ada. I post the identity of this del operators. Identity is we can use it. We can use in the mathematical works. So but I'm not focusing my lecture today. I'm not focusing on the identity. I'm focusing on creating this curvilinear coordinates of del operator, Laplacian operator, curl. Okay, now what happened? So now we can use this thing. We can use the same thing, the same concept. Dot, which is now this A, E, A1, E1, which is this, and we take this as A, B. So we take the first one is A1, H1, H2, H1, H2, H3, okay? H1, H2, H3, okay? A1, H2, H3, and then this is A, and then del operate upon B, which is this one very easy, very easy. You can guess, okay? I just ask you later. You can guess what it is. We can try what is this. If you know, I mean, your vector is good. Okay, now another one is this one B, which is tadi U2 cross product U3, and then dot del is one. Del A1 H2 H3. Okay, so this A is A1 H2 H3, B is this one, kawan ni, and this, okay, this one, dot product, this one, dot product, and then this A, this one. But we can simplify this. Wow, how? This dot product, this become what? This dot product with this become what? Okay, very easy. U2 cross U3, right? 2 cross 3 3 become what? Equal to, okay, dot product. Okay, now we come to this one, right? U2 U3 is E1 E2 H1 H2 cross E3 H3. Okay. Jadi E2 E3 become what? E1. We can take out this thing, just concentrate on that, and concentrate on del of E1. What happened if del on E1? Okay, we use this one. If we use this one, okay, E1, E2 of course is 0 because we concentrate on this. Okay. So E1 dot product with E1 dot product with E1. This one become 1. So operate with differentiate with 1? 0. So this is just become, the whole thing is become 0. Okay? Got it, everybody? Tak apa, kalau tak faham, I can explain later. I can explain again, no problem.
The whole thing as in del dot.
Yeah, the whole thing as del dot del U2 cross product del U2 become 0. That's why we can say this thing is 0. This whole thing is 0. Kan very easy. So what left is this? Okay, this one This one, this. Is it okay, this one? Okay, alright. Okay, now we have this. So far okay, everybody? Everybody okay? Everybody okay? All right. Okay, now we take this one. So we know 0. So what left is this? This one. Del dot A1 E1 is equal to that one. Okay. Del U2 cross product del U3 product with del A1 H2 H3. Okay, this one very easy. Can you guess very fast? E2 H1 E2 over H1 cross product E3 over H3, right? E2 over H2 cross product H3 over H3. And then this dot product, and we okay, never mind. We just take this for a while. Concentrate on this first. This one, of course, we can use this one. We can use this equation to expand it. Become become what? E2 E3 become E1 over H2 H3. Okay, and then multiply a dot product with this. Okay, so dot product of that, del of this is equal to, we use this what we have calculate just now last time. So 1 over H1 d U1, and then this A1 H2 H3, and then E1 plus 1 over H2 A2 A1 juga, still A1 H2 H3, and then E2, and then 1 over H3 du3 A3 H1 A1 H2 H3. Okay, the same some H1 A1 H2 H3 A1 H2 H3 A1 H2 H3. So yeah, so this we use that. But okay, now this thing we want to this whole thing is this whole thing, this one is this. You dot product with E1 over H2 H3. So E1 dot product with E2 becomes 0. This one E3. Sorry, E3 dot product with E3 become 0. Okay. What left is just over here. Over here, this portion, E1 dot E1 become 1. So what left is del, which is this one, which is del dot A1 E1, which is this one, is equal to this one is del dot A1 E1 is equal to this, is equal to E1 dot product with this one, and E1 dot product with E1 become 1, E1 dot product with E2 becomes 0. E2, what left is here only, which is 1 over H1 multiply multiply with H2 H3. E they got dot product with E become 1, so 1 over H1 H2 H3. 1 over H1 H2 H3. And then du1, okay, and then A1 H2 H3. So we have this. This can be a pattern. Okay. Got it, everybody? So far? Okay, I this one okay, and then I work on this side. Is it okay? Erase this one. Okay, this one is very elementary, easy. This one Cartesian coordinate. I think you know already. H1, H2, H3. So what we have now is this. Del dot AE A1 E1 is equal to 1 over H1 H2 H3, 1 over H1 H2 H3, and then du1, and then A1 H2 H3, A1 H2 H3. Okay, very easy. So so the same pattern, we can use the same pattern, or if you cannot get the same pattern, if you're not sure with the pattern, you have to rework again as this one, as this procedure. You have to rework again and get it. But actually, you can get the pattern. So, for example, dot A2 E2 become, this one is same thing, H1 H2 H3, and then this one is du1 du2, no du2, no A2 E2, lepas after A2 the same guna A2 jadi H3 H1. Okay, and then very easy, A3 E3, the same thing, du3, and then this is A3 H1 H2, the same positive permutation. Okay, positive permutation. If you're not sure with this, you will have to rework again. We will work one by one. Try. You can try as an exercise. You work again. You found is it correct? Sekejap, saya disap call. Sorry. Okay, now we have this already. Now we go back to that one. So now del, since del is this one, since del Laplacian of psi is that one. Okay, is that. So we can put here. And then d e. Okay, you can okay, because it is the same. You just have to add them together. Then together, this whole become the Laplacian of psi. Okay, because the Laplacian of psi is able to add them together. So you can factorize even. Factorize because it's all the same. This one. Only inside, only this differential is not the same. So you just factorize it. H1, H2, H3. Okay, this one is, and then du1 A1 H2 H3 plus du2 A2 H1 H3 H2 H3 A1. But actually it doesn't matter. It doesn't matter because 3 and 1 is it can switch. It can what we call associative. Okay. Okay, plus du3 and then A3 of course jadi H1 H2. Okay. But not yet finished. What is A1? What is A2? What is A3? Okay. So A1. So that one. How? Okay. How we can relate this A1? Okay. So I relate this. So we have this already. We almost get it. Almost get it. But the problem is, what is A1? How we want to translate A1 into A1, A2, A3 into coordinate term. Okay. Atas Okay, that's one. Okay, now we have this. I can erase this. Okay. All right, everybody. Now, apa dah? Is it okay? Oh, okay, lama lagi. No problem. So okay, too fast or what? Too fast, okay. I slow down a little bit. So, tapi so far okay, boleh catch up. Understand why we have that, okay? Already? Okay, alright. Now, just another problem is, what is A1? What is A2? What is A3? In curvilinear coordinate form. How we going to do that? We know that this thing. We know that this A, the vector A is A1, this versus, plus A2, plus A3. Okay, plus A3. Oh, some people just put a sticker here. Come on. So rosak ni punya. Everything put sticker is so crazy. I mean, this is board. I mean, mathematicians love chalkboard. Theoretical physicists like me love chalkboard. We don't we. It is like a what we call insult to our intelligence if we put just what PowerPoint. we don't teach mathematical rigorous subject using PowerPoint. PowerPoint is just to display whatever, like business school, of course they use PowerPoint. But in mathematical heavy school, heavy subject, you have to show the mathematics. Okay, all right. Of course, if the best thing if ada smart whiteboard kan, we just, but it's very expensive lah, of course. Even in top university like MIT, Harvard, Princeton, they use chalkboard. Even bigger this. Okay, A1, A2, A3. Okay, this one. So this, and we know that A is this. We take A because we want to get. If you remember, this delta psi, del psi or the percent of psi is dot product with this one. Okay, right? And we take this as A, which is a vector also. So this dot A. Okay, so this means that A is which is A1, A2, A3. This A as a vector is a this one. Is a del is the gradient of psi, which is equal to 1 over in the form of curvilinear coordinate. This one. H1 du1 phi, okay, E1 plus 1 over H2 d psi du2 E2 plus 1 over H3 d du3 E3. Okay, got it, everybody? All right. Now we can relate to A1. So A1 is what? 1 over H1 d psi du1. A2 is 1 over H2 d psi du2. A3 is 1 over H3 d psi du3. Okay, right, everybody? Boleh? Now just plug in back into that equation, which is kalau kita plug in back, so we get the thing lah over here. So the Laplacian here is Laplacian here in term of okay, sebab dia ada psi. So okay, we just do it here and then we put here. That is just operator. This one just operator. I mean, you just ingat the operator. This one operator. So this one still a function operator. So now the delta psi just plug in. Del psi or the Laplacian of psi is equal to 1 over H1, H2, H3. Okay. The one del d1, del d1 ataupun macam mana? You tak nampak kan? So I atas okay, I atas macam mana? I atas and then I erase atas. Okay? Okay, this one, so sambung kat sini lah, nampak. So, nak sampai sini. Okay? Is it okay? Dah okay dah kan? Kita akan use this one. This one kita dah dapat dah. Kita kita akan use this one. This one. This one is 1 over H1 O2. And then kita use this one. A1 kita ganti dengan atas tu. Ganti dengan ganti dengan atas tu. A1 A2 kan. Jadi du A1 okay, du D1 and then A1 is okay, A1 is actually we can switch. A1 is this one. Okay, just tulis macam biasa dulu. Kita adjust balik. We adjust balik 1 over H1 D psi du1 and then H2 H3 and then plus du2 and then 1 over H2 d psi 1 over H2, okay, silap. 1 over H2, d psi du2, okay, and then H2, H3, H1, okay, plus another one is du2, 1 over 3, this one 3 lah, 3, du3, 1 over H3, and then d psi du3 and then H1 H2. In fact kita boleh readjust kedudukan semua. Dia bukan operate with this. It's not operate with d phi. Operate with d phi du3 is only psi. So we can put this here. We can put in front of this differential. Okay. So we can have this one like this. 1 over H1, H2, H3, du1, and then H2, H3 over H1, okay, and then d psi du1 plus du2, and then H3, H1 over H2, okay, d psi du2, okay, plus du3, and then H1, H2, H3, and then d psi. A lot of pattern, good pattern. du3. That's it. So this is untuk kurungan this one. So this is the del operator, del Laplacian Laplacian operate upon psi in the curved linear coordinate form. So the Laplacian operator on Lie is we just take off psi. We just can say 1 over H1, H2, H3 1 over H1, H2, H3, and then du1, and then H2, H3, H1, du1 plus du2, H3, H1, H2, du2 plus du3, then kurungan H1, H2, H3, du3. So this is a template of Laplacian. So sorry. Okay. So we have this and we have this. So as usual, we want to find the Laplacian in spherical coordinate. We just have to find H1 in spherical coordinate, H2 in spherical coordinate. Very easy. If you remember the first day, H1. Let's say for example, H1, which is dr du1, right? dr du1 apa dia? R position vector divide position vector. R ni position vector. Di sin R sin theta, cos theta, all that. You can find it. You refresh balik book ni. So, never mind. Later after we finish this thing, and then we take example of how we want to get in del in spherical coordinate by using just plug in this thing. Okay?
Doctor,
Yes.
there's du over du outside, there's d over du at the inside, why cannot combine? D square over du.
Oh, this one. Oh, shit, sorry. Yeah, have tutup kurungan ya. This one, right? This whole one whole thing. So this, sorry. Okay. Is it answer your question? Is it? Oh, okay. Sometimes I cannot see.
This one is du over du1 and this one is du over du1.
Yes.
Kenapa tak boleh combine?
Oh, tak boleh.
Tak boleh?
This is one whole function to be operated with this. So this one is just I mean, you got to find H2, H3, H1, and then this one is to be operated with something. Okay. I mean, let's say for example psi. So psi. So if you psi, you see, psi. You operate it with psi. You operate it with psi. You do one. You calculate first this one, and then you multiply this one, and then baru you operate it with this one.
So that thing has nothing to do with the d psi over du1 lah.
Which one?
The d over du1
Ah.
cannot combine that.
Cannot combine. This you have to calculate this one. Okay, you have psi. You calculate the psi du. You calculate that, and then you multiply with H2, H3 over H1, and then you get the one whole result. And then baru you operate with this du1 later. So you cannot operate simultaneously. Very dangerous. People make mistake of this. Okay. So okay, now kita tengok how we can this one more. This one we already done this. This one divergence. Divergence ada kita buat tadi. This one. Divergence of A. Divergence of A. Okay, there operate. Divergence of A kita asal kita buat tapi kita tak perasan. Sekejap. Ada note saya tengok sekejap. Divergence of A kita dah buat. It's become yalah. Divergence of A is somewhere kita dah masuk tadi. I mean this one. Divergence of A is divergence of A. Boleh padam? So I just nak tulis balik. Actually the divergence of A we already have done, but I forgot to put over there. So divergence of A, which is divergence of A E1 plus this one, kan? Ada kan di note down? Okay, you note down tadi. So this one is 1 over H1 H2 H3, then A1 H2 H3, macam mana? A1 H2 H3, I think you got it tadi. Oh, sorry. Differentiate lah, D du1 A1 H2 H3 plus D du2. So all the same thing. Jadi A2 H2 H3 H1 H3 H1 3H1 plus D du3 A3 H1 H2. And then kutub kurangan. So divergence of A, which is divergence. If you operate divergence, you always get no more a vector, because divergent dot product del dot product with some vector, you got scalar. So that's why nampak scalar saja, dia tak jadi vector langsung. It's not becoming vector at all. So divergence, so kita letak sini tadi. Dia punya eraser tak ada eraser here. Okay, I erase this one. I think you know already. I erase that. This one okay? This one. I just want to put the divergence there. So the divergence of A is, so this for you to, this is like the result of what we are discussing now. So divergence of A is 1 over H1 H2 H3 D du1 A1 H2 H3 plus D du2 A2 H3 H1 plus D du3 A3 H1 H2. Okay, it's divergence of A. We have that. Now we want to find this in terms of basis curvilinear coordinate. Okey, ada masa lagi. Right, it is this one, okay. Now, as usual, we explore the mathematical trick of it, right? Now we have curl. We have curl operator. It's a little bit complex, a little bit, but it's okay. You can do it. We can do it. So we can explore the mathematical tree. What is the mathematical tree of that? Mathematical of that is this: you try to find the curl of A, curl of A. Okay, curl of A. So now, instead of now we want to find the curl of A. In fact, we want to find the curl of A. But, okay. But of course, if it's Cartesian, we know already. If it's spherical coordinate, you know already. But usually, maybe if spherical or Cartesian, cylindrical, maybe you hafal the structure of it. But you know where it come from, okay? So this one is, maybe you memorize it, is A1, E1, because A, never mind, I expand this first, for you to A2, E2, plus A3, E3, okay? We expand this, we got cross A1, E1, plus cross product A2, E2, cross product A3, E3. Okay. So we tackle the first one, and sure we can see the pattern. So cross A1, E1. So how we want to tackle this? If you look at this is the vector. This, okay, how we going to do it? No, okay. So E1. So we know that U1 is equal to E1 over H1. U1 is E1 over H1. So E1 is H1 del U1. Okay? H1 del U1. Okay? So we put here cross is equal to, now is equal to, so del cross A1 E1 is equal to del cross A1 H1 del U1. Okay? All right. Now we use the identity. You see, this is just a scalar. So we say, let's say for example, this is scalar A1 H2. Take it as a scalar. So this is let me see. I take it as a phi. Phi cannot lah. B lah. See A lah, A. Which is scalar, and then this one is what we call B. This one is B, the back vector itself. Okay, just like this, you know. So we can say cross product what happened to, so A, B, B. Okay, what happened? So becomes del operate upon phi A, because this is not a vector, so you just have to operate like gradient, operate right away, and then cross B, and then plus, okay, and then plus, which is A, and then del cross B, A del cross B. Okay, kurungkan sini. So that's mean the same thing. So we can use this method as this. So del cross A1 E1 is equal to, this one is del, okay, we take A. So A is H1 A1 H1. So operate upon A1 H1, and then cross product with with del 1 del U1, okay, plus A1 H1 and then this del cross product with del U1. Okay. Obviously, del cross del U1 jadi 0, is it? Kan? Kita check balik. Cross product with E1 over H1. Okay. This one is this one del is this. And then cross product with E1 over H1. So 1 over H1 del U1 E1 cross product with E1, which is 0. Very good. Very good. Kata I pun reti pun. Aduh, okay. Alright. So of course this 0. If tengok macam ni, tengok macam ni 0. Tapi tengok if V1 is not 0. Okay. Now del E1 what we have is this one cross E1 over H1. This one del E1 H1. Okay, that's okay, del okay, it is now okay. Air tadi okay. Okay kan? Good. Sudah ini pun sekali berapa? Okay, now what we have here is this. Equal to cross product over H1. So this you take 1 over H1, you take this one D A1 H1 A over D1 and then multiply with E1 ni. I mean, the unit vector. So another one is 1 over H2, but you will get cancel it. Vector A1 H1 1 E2 plus 1 over H3 D DU3 A1 H1 E3, but you cross product with E1. Cross product with E1 H1. So what we have 1 over H1 E A1 H1 E1, and then E1 cross product is 14. Is 14 cross product E1. Okay, kemudian apa? I rewrite again. I rewrite it. Tak nampak, tak jelas. Okay, we expand this. Expand this 1 over H1 D DU1 A1 H1 E1 plus 1 over H2 D DU2 A2 H2 E2 plus 1 over H3 DU3 A3 H3 E3, and then in the cross product with E1 over H1. So E1 over H1 tadi del U1. Okay. So we cross product what happens? 1 over H1 D DU1 okay, of the A1 H1 E1 E1 0. Nama ini put back E1 cross product E1 0 plus okay, 1 over H2 H1 D DU2 A2 H3 E2 cross product E1 H1 kita baru tulis already 1 plus 1 over H3 H1 we can see the pattern also DU3, and then A3 H3, and then this one is E3 cross product E1. Okay, ada lagi? Yeah, which one? Ni A1 and this one. Ni A2 A2. H2. Okay. Okay. H1 H1. Sorry. H1 H1. Okay. Wait. Memang betul. Okay. H1. Yeah. H1 H1. Everything is H1 H1. H1. Everything is one, and then this one E1. This one is 0. This one, everything is E1. Then this one, you work of it from here. This E1, H1. So this one, H1. One, H1, sorry. Okay. Sorry, everybody. Very good. Sorry. Yeah. One, H2 still.
And now we bring H1 into the bracket. Then H2 H1, then the first part also needs to H1 squared, kan?
Yeah.
Okay.
This one, the first H1 squared, H1 squared over here. This one H2 H1, H3 H1. Okay? Alright. But this one, no need of concern because E1 cross E1 it becomes 0. What left is this What is these two? But you have to cancel, we have to look at this. E2 cross E1 become what? E2 cross E1 become negative E3. E2 cross E1 become negative E3. Is it? Okay, everybody?
Yes.
E3 cross E1 become
E3
E2, positive E2. Good, very good, very good, very good. Okay, now we have equal, okay, 1 over H2 H1 d du 3 A1 H1 and then E3 minus, tapi yang positif lah, minus this one. One is 1 over H2 H1 d du2 du2 A1 H1 E3. This one E2. E2, right? This one E2. Positive. One positive E2, negative E3. Okay? We have that. Okay? Okay, alright.
Okay. That one is H1 H3 H1 kan? The first one.
E2. H1 H1 A1 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 H1.
No, 1 over H2 H1.
H3. Yeah. Because it's H3. H3. Have to be careful. Okay. Go for it. What time now?
12:44.
12:44, okay. The same method can be done, the same method as I did just now. Okay, I tak nak go through deeper. So you have this. So actually, the cross product of A is equal to del cross product A B1 plus del cross product A B1 E2 plus and then plus del cross product E3 and then you have you have this 1 over H2 H1 U3, okay. U1, U2. Okay, alright. Okay. So after this, I just masuk terus lagi kan. Okay. I buat dictionary to delta A. So you akan dapat B1 after panjang after tempat I will later I show you to this because I just want to finish this. Okay. H1 the same procedure as you. The same procedure and then you add that together and you have to rearrange like E1, E2, E3. You have to rearrange. But never mind, I have this note. I will just send you so you can check this calculation. Okay, you finally you will have something like this. You will have something like this. H1, E1 over H1, H2, H3. After this, after you do this, D, DU2, A3, H3 minus D, DU3, A2, H2. Okay, after you rearrange, and then you add them together, the H2 minus this one minus you after you arrange this one you get the second one you get minus E2 over H1 H2 H3 and then multiply is DU U1 A3 H3 minus DU3 A1 H1. Okay. Okay. The last one is H3 E3 and then divide by H1 H2 H3 and then this one is del DU1 A2 H3 and A2 H2 H2 minus D A1 H1 over DU2. Okay, and this you can make it into okay. That one you can transform this into the curl determinant form. Okay, are you ready? This one step ni algebra sajalah. You just have to hati-hati. Okay, is it okay? Okay, you try yourself. Kalau memang sometimes we make mistake. Dah tak betul. So you have to be careful in doing this, just algebra, and then you have to rearrange that. Try to prove this thing. Try to prove it as an exercise. By this lah, daripada asas ni, and then you expand this one. Better be careful when you do the cross product everything. When you do this, better be careful. And then you expand, and then this one is for only A1 dengan E1 component. But for the whole thing, for the del operate upon a curl of A, you have to add them together. When you add after you add them together, it becomes this. And this you can transform it into the determinant form, which is cross A is equal to, the common factor down there is H1, H2, H3. H1 is, so you can say 1 over H1, H2, H3, and then determinant of the. So the common over here, this one, this component, here, the basis vector form is H1, E1, H2, E2, plus H3. What the word so skip? H2, E2, H3, E3. Common factor one is the one, and then the other one is the okay. H1, E1 operate with D du2, A3, H3. Okay, how we gonna do that? Okay, so we take this one, D du1, D du2, then D du3. Okay. Okay, so du2 H3 over here. So this one A1, H1, A2, H2, A3, H3. So let's example this that the first term H1 E1 D operate on this one A3 H3 minus DU3 operate with. Okay. Got it? So what we have now is that curl is this lah. Okay, curl of A. Okay. H1, E1, common factor H1, H2, not just E1, not just E2, not just E3, tapi dia multiply H1, H2, H3 respectively, and the differential form D1, D2, D3. Okay, I think 54 already. So from here, if you want, you can, okay, let's say for example, yes, you remember ds squared this is for spherical coordinate, Which one you want to, okay, spherical coordinate, I just, dr squared, r squared, d theta squared, plus r squared, sine the d phi squared, right? This can be written as dr. ds squared can be written as dr dot dr. That means the dr is dr plus r d theta e theta plus r sine theta d phi and e phi. If you look at this, you can easily find it. This is H1. H1 is 1. This is H2. H2 is okay. What is it? It's we can write this thing in the form of this H1 du1 plus H2 du2 E1 plus H2 du2 E2 plus H3 du3 E3. So you can look at this. ER is to E1, E theta is to E2, E phi is to E3, D U1 is R, U2 is U theta is U2, phi theta is U2, phi is U3. Okay, H1 is 1, H2 is R, H3 is R sine theta. Yeah. And then you just plug into here, H1, H2, H3, you get the curl of in spherical coordinate. Okay? Very easy. Kan? Very easy. Right? Of course, the most easiest one you hafal. One you want to operate the thing. But how this thing come from? This thing come from the curvilinear coordinate. The curvilinear is very fundamental. You have this thing, you can use a lot of things. You can manipulate a lot of coordinate system, not just spherical, apa ni, Cartesian, or Cartesian very easy lah. Not spherical, cylindrical. There are many other coordinates, not just do those two, three. But the overall coordinate system, the most generalized coordinate system is the curvilinear coordinate system. Okay, everybody, that's it for today. Next week kita sambung the application of this. Application of this.